Let's graph this polynomial. It is a degree 5, and we're going to start off with finding the end behavior. So the end behavior depends on this leading term. It's an odd degree, so it's going to do opposite things on either side, and it's a negative leading coefficient. So that tells us it goes up on the left and down on the right. Now looking at x-intercepts, we go through each of those factors, and this first factor will give us an x-intercept of -4, then this one gives us x-intercept of -3, and this one gives us x-intercept of 1. -4 and 1 have even multiplicity, so when we get to graphing, we're going to make sure that we touch the x-axis and not cross at those. So plotting those x-intercepts, we got the -4, -3, and 1. Now looking at y-intercept, that's going to be the constant term, so -96. I'll label this point right here -96 and put a point there for the y-intercept. Now we can graph it. Because the graph goes up on the left, when we start to graph from the left to the right, we're going to start above the x-axis. Now, because -4 has multiplicity, that's 2, it's even, we're gonna touch at that point, make a turn, come back up, and then we want to go through that x-intercept of -3, so we need to make a turn, and we're going to cross there because that's multiplicity of 1. We need to go down, make a turn, go through the y-intercept at -96. And then we have the x-intercept at 1. This one also has even multiplicity, so we touch and make a turn, and then the graph goes down from there, which matches up with what we said. This next example, we are given a polynomial and a 0 of 3. We want to find the other zeros and sketch a graph. Now notice that we can do a little factoring to start off with. Each of those terms has an x in it, so we can factor an x out. So the x goes out in front, then we have x cubed minus 3x squared plus 7x minus 21. So using that 3 that we know is a 0 and the coefficients from that factor, we'll do the synthetic division to get the other zeros. So go through this process. Okay, so we get 0 for our remainder, which is what we would expect if 3 is a 0. So let's write down what we have factored wise. So f of x equals, we've got the x out in front, and then x minus 3, and then we've got the factor that's got the coefficients of 1 for the x squared term, 0 for the x term, so there's no x, and then 7 is the constant. Okay, so there we have it in factored form. And now we want to solve for the zeros using this factor, x plus 7. So x squared plus 7. So x squared plus 7, we set that equal to 0. Take the square root of both sides. We're going to end up with, go over here, x equals plus or minus, bring the negative out in front as an I, and square root 7. Okay, so the zeros for this polynomial are 3, the one that we're given. For the factor of x, that's going to be a 0 of 0. And our other two zeros are the imaginary zeros, I square root 7 and negative I square root 7. Okay, so when we have one complex solution, we're going to have two, and they're going to be conjugate pairs. So that's what we have there. Okay, let's go ahead and graph this now. Okay, our let's see, our leading coefficient was x to the 4th, so it's positive leading coefficient and also even degree, so it's going to go up on both sides. Our x-intercepts are 0 and 3. Those are our only real zeros, so those are the only ones that are going to give us any x-intercepts. Okay, now as far as y-intercepts goes, if we go back to our original polynomial, you'll notice there's no constant, so the y-intercept is equal to 0. So the y-intercept is equal to 0 because the constant is 0. There's no constant term. Okay, the other thing that we want to now do is just put a curve through those points. So we're going to start above the x-axis. We're going to go through the x-intercept at 0. We need to get to the other x-intercept at 3, so we're going to make a turn and go through that, and that's it. Okay, we only have 2 x-intercepts, so we're just going to have one term for this particular polynomial function.